This lesson is known as power of a product. The names can be confusing, but if you pay attention, you won't need to memorize the name. You will just need to know what to do when you see a monomial raised to a power. So power of a product says this. To find the power of a product, find the power of each factor and multiply. The key thing for you to remember is each factor. Therefore, it's also important that you be able to identify what each factor is. If you can identify each factor in a monomial or in an expression, then you'll be able to raise it to the power and it won't be a problem. Let's check out example 3. Example 3 says 4p to the third, all raised to the fourth. Okay? Now, if it helps, I would like you to think of the distributive property. I need this exponent of 4 to be applied to each factor inside the parentheses. Will someone tell me what are the factors inside the parentheses? Micaiah. Very good, Micaiah. He said that P is a factor and 4 is a factor. So what needs to happen then is this exponent needs to be applied to the factor of P and also 4. So what I'm going to do is I'm going to rewrite the factors raised to the third power. So I have 4 raised to the fourth power times P to the third, and that is also raised to the fourth power. Well, 4 to the fourth power, we can simply leave it that way, or we can write it out for the number that it is, which is 256. Over here, we have P to the third raised to the fourth power, and that's a classic example of what we worked on yesterday. Power of a power means we multiply the exponents. So I'm going to do 3 times 4, which equals 12. Now I have P to the 12th. So 4 to the 4th times P to the 12th, or 256 P to the 12th. Okay? Now, why does this work this way? Well, if we were to write out this example, 4p to the third raised to the fourth power means I have 4p to the third how many times? 4. Okay, so this 4 tells me I have what's inside 4 times. So if I were to write it out, it would be 4 times p to the third times 4p to the third times 4p to the third times 4. It's not a very good third, is it? P to the third. Okay? Well, remember, I told you that you can rewrite multiplication any way you want. Donovan told us yesterday about the commutative property of multiplication. So I can rewrite this, and I can put all the 4's together, which would be 4 times 4 times 4 times 4, and then put all the p to the thirds together, which is p to the third times p to the third times p to the third times p to the third. Well, 4 times 4 times 4 times 4 we know equals 256. P to the third is p times p times p, and then I have that 3 more times p times p times p, and then 3 more p's, and finally 3 more. And altogether, when I write it out, how many p's do I have? 12. I have 12. So it can be rewritten 256 p to the 12th. So we could do that whole step, all of those steps every single time, which is fine. And some people, it's good for you to do that. Or you can remember that this factor of 4, the exponent of 4 needs to be applied to every single factor in the parentheses. Let's try one more example. Here we have 3c to the fourth raised to the third. Someone tell me, what are the factors? How many factors do I have inside the parentheses, and what are they? Tay. How many factors do I have? Two. And what are the factors? No, 4 is an exponent. What are my factors, Dallas? 3 and C. So here's my factors, 3 and C. And remember, this 3 has to be applied to each of those factors. So I'm going to rewrite this, 3 to the third times C to the fourth raised to the third. Well, 3 to the third is what? 3 times 3 times 3 is 27. C to the fourth raised to the third. I have a power raised to a power. So what do I do to the exponents? Multiply them. So what's 4 times 3? So my answer is 27 C to the 12th. Okay? All right. Now, what's the difference? Look in your books and tell me what's the difference between example 3 and 4. Look in your book and tell me what's the difference between example 3 and example 4. Tay thinks he can get this right. Go ahead.
First off, 3 got a negative. Number 2 has a negative.
Okay, so Tay said there's a difference in negative signs, which is true. What else, Dallas? Excellent. That's the perfect answer, Dallas. Dallas said there are more factors, okay, which means we got to pay a little bit more attention. So I've got negative 2, m to the 7th, n to the 6th, and all of this is raised to the 5th power. Now, how many factors do I have in here, Bianca? How many factors do I have in parentheses? 3 factors. Excellent. Trey, tell me what the 3 factors are. Trey says negative 2. What else? M. Very good. M, and what else? N. Excellent. So I've got to take the power of 5, and that's got to apply to each factor, the N, the M, and the negative 2. So I am simply going to rewrite this. Negative 2, make sure you put parentheses to keep that negative straight, to the 5th power times M to the 7th raised to the 5th power times N to the 6th raised to the 5th power. Okay? Now I can just simply go from there. What's negative 2 to the 5th power? Very good. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2, which will give me, I believe it's negative 32. M to the 7th raised to the 5th power. What do I do with M to the 7th raised to the 5th power? I'm going to multiply the exponents. Very good, Devin. What's 7 times 5? 35. So I've got times M to the 35th power, and then N to the 6th raised to the 5th power. What am I going to do, Nikaya? Very good. We're going to multiply 6 times 5, which is what? 30. And my answer will be negative 32, M to the 35th, N to the 30th power. All right, let me show you one more, and then we'll let you get started on your practice problems. Okay, last one. Who thinks they can do this one off the top of their head? All right, Devin thinks he's got it. Devin, what do we got? Yep. Very good. All right. So Devin recognized the 3 factors. He raised the power of 2. Each factor he raised the power of 2. Now if we figure this out, negative 4 squared is 16. P to the 5th raised to the 2nd is what? P to the 10th. Q squared is just Q squared. All right, excellent job. There's also an example of a word problem on the other side. it's very important to just pay attention to the words and try to find an expression that matches those words. Okay? So I think it said find a volume of a cube with side lengths of 6mn7. So help me out here. If I've got a cube, what do I know about a cube? What's one of the properties about a cube? All of the sides are the same. So I've got to do length times width times height, right? I've got to multiply a side by itself 3 times. So if you give me one side, which is 6mn to the 7th power, what's a way that I can multiply that by itself 3 times? Raise it to the 3rd power. All right? And then if I just simply write that out as 6 to the 3rd, m to the 3rd, and n to the what? I've got 7th raised to the 3rd, 21st. Perfect. Okay? So the word problems really don't have anything different other than you've got to think clearly and be able to take the words and put it in the form of an equation. Okay? I would like you to try the got it's at the bottom of the page, and then we will move on.